Hello, all. So let's continue with the bag of words approach. And we motivated in last lecture that why we need the uh, bag of words approach just to convert our text into vectors. So let me take you to a little bit of a detour. Okay, it will be quick and easy. Let's say that for my review one here, I'm saying that hypothetically I have converted this into some vector and I'm just plotting it in our two-dimensional space. Let's say review one, I converted into a two-dimensional vector. Let's call it 1 comma 2. Okay, you can write it like as a vector like this 1 comma 2, but it's in here where we plotted it. And let's say similarly we have a lot of reviews that are being plotted here. Somehow we converted this into a vector somehow. Okay, and consider it as a 2D because we can plot it here on the blackboard. And let's say we have some other reviews, okay, which are plotted here. And somehow if we can convert all those reviews into a vector such that all the positive reviews are on one side and clubbed together somehow, and all the negative reviews are on the other side and clubbed together. Now if we want to classify any new review as positive or negative, what we can do simply, human intuitive logic can be, if it will be on this side, okay, where on the side where all the points are positive on this side, then we can say it will be positive. And if the new review, let's say, come somewhere here, then we will say it high chances of that it will be negative. So what can be a simple thing that can separate these two things? Can be a line, they can be anything, right? But let's say right now our data is linearly separable, so it's a linear boundary that we can draw right now. Okay, so that's how uh, machine learning works. That this is simply similar to y equals to mx plus c, right? So it's like finding a best line, that is the parameters m and c, which can perfectly separate this positive points from negative points, right? So here comes the need. So now we can leverage the power of linear algebra, right? Or our basic geometry, line, plane. In 3D, it will be plane, right? That's how it's work. And this is the reason why we there is a need to convert words into vectors. So that's why I am showing you that why this bag of words approach is needed. Okay, so let's still motivate ourselves that how the bag of words approach work. Okay, so first step is, let's say we are given four reviews like this: R1, R2, R3, and R4. Now that this is human readable thing, we can easily know this. But how can we convert into a vector? So one simple approach is called bag of words approach, in which what we do is, let's say we are given this four reviews only, okay, in our entire data set. So what we'll do, we will create a bag. Okay, so let's say I'm creating one bag. Okay, I hope this looks like a bag. Okay, and in this bag, we will put all the unique words that occurs in our data set, only unique words, and we call it a dictionary. It as a dictionary in Python, right? So just we create a dictionary of all unique words from the entire data set. Okay, and now let's say hypothetically, I'm not counting all these words that I have written here in the reviews, but let's say hypothetically that our entire data set consists of 10 words. Now what bag of words approach says that for here we will be having 10. Let's say it's 10 now. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we are left just with one. Let's put it here. Okay, so we have 10 boxes right now. So this is one vector now. And what we can fill in this vector? For example, let's say this corresponds to word this box corresponds to word this, and this corresponds to was, this corresponds to don't know thriller, this corresponds to end, this corresponds to special, and so on. Okay, so let's say total we have 10 words. Here we have more than 10 words in our entire data set. But let's say we have just 10 words. What we will do for any review, how we can write now the vector. So for example, now we have to write vector for this. Okay, then this occur once, so I'll write one here. Was occurs once, so I'll write one here. Let's say this box is for A and A occur once, so this, I'll write A here. Now was occurs here twice. What we will do? We will do write two here, and this is how we will get some numbers based on the occurrence, and that will be our bag of word representation. This is how we convert the entire review R1 into a vector form. Let's write R1. Similarly, you can do it for R2, R3, and R4, or any n number of reviews. But as we know that since our data set or our number of unique words will be more, this will be a really big vector, right? This 10 is just for example. This can be 50,000, 100,000, don't know, right? So this is what the problem is with the bag of words approach, that most of the rows, right? Most of the cells, let me put it that way, will be empty. So that's why bag of words can be considered as a sparse vector. Why it's sparse? It's an English term. Sparse means like most of the things will be empty. Right? Sparse matrix, if you have heard, most of the elements in the matrix, if they are zero, then we call it as a sparse matrix. Similarly here, if most of the elements of a vector are zero, then we call it as a sparse vector. And bag of words representation gives us a sparse vector. So now let's go back to our code, that how things are done in Python. So here simply I'm importing a lot of libraries, but what we will need is this count vectorizer. Okay, so we need NLTK and Matplotlib, Seaborn, everything, pandas, SQL. Okay, we don't need much, but I have imported it here because in future we'll need it. But here right now, what I specifically need is this one. Okay, and nothing much as of now. This will be most important. So just ignore rest if you want to. And what we'll do, we'll just simply write, this is our bag of words representation. So we will just simply instantiate first the count vectorizer. Now what we will do, we'll store it in the count vector. Okay, whatever we instant. So we created an object of this count vectorizer class. Now we are just using a method called fit method on just the review column from our data set. Correct? Now what we are doing, we are saying that just print some features. So get some features name out. This is also one of the method. So it will just give us the feature names, 50 feature names, top 50, not top 50, but just first 50 that it considers. And now what we'll do, firstly we fit and then we'll do transform. Okay. So firstly we instantiate to repeat, then we fit to the entire training data set. So it learns from the entire training data set, and you will see how many number of unique words we have. You can see 175,000 around. Okay, number of unique words. Correct. And you will see we have 50,000 movie reviews, right? So for each review, okay, we have now a vector of size 175,779. Okay. And you will see some features like AA, double A. This is alphabetically ordered, it seems. So you can see there are some slangs in Hindi as well, like Ailia and whatever, right? So this is how it works. A simple approach to convert word into a vector form. And we will see how Naive Bayes uses this now.